One of the labs, the second lab that you'll be doing during Level 2 Atomic Concepts is something called the Pennium lab, which really coaches you through and helps you understand how the atomic masses are derived for the periodic table. So that will be something you need to learn how to do, and there's a little calculation, really easy one, that you'll have to pick up, and I'm going to demonstrate how to do that right now. First of all, though, a little review. Isotopes, again, are different masses of the same type of atom. So that again happens as these particular atoms with, in this case, chromium 24 protons has a different number of neutrons in the nucleus. So chromium can have either 26, if you do the subtraction here, neutrons with its 24 protons, could have 28 neutrons with its 24 protons, 29 neutrons with its 24 protons, or 30 neutrons with its 24 protons. Again, to figure out the number of neutrons, subtract the atomic number out of the atomic mass. All right, having said that, what you would find to be true if we were to come up with this data, again, that's on the periodic table, this has been studied time and again by various universities that would have a machine called a mass spectrograph. Pretty common machine. And what you do is you take a naturally occurring sample of the element, in this case chromium, you throw it in the machine, and the machine will sort of sort out the various isotopes by mass. It'll report the exact AMU mass. Notice they're not whole numbers here because we've been saying that a mass of a neutron or proton is about 1 AMU, but they're slightly less or more. And when you take the exact number, you get these fractional numbers here. And then it would also sort them out by the mass, so you would know how many of each type you had. So for example, if you had 1,000 chromium atoms, you just had this sample with 1,000 atoms in it, you would find that 83.8%, or out of 1,000, 838 would be chromium 52, which apparently is the most abundant isotope of naturally occurring chromium. The least abundant isotope comes out 2.35% of the time, where out of 1,000 atoms, about 23 or 24 would be chromium 54. So of course, the isotope that has the most influence on the atomic mass calculation is the most abundant one. Now, how do you do the calculation? Real easy. You take the AMU mass and you multiply by the percent natural abundance expressed in decimal form. 4.35, remember from kindergarten, is expressed as 0.0435 in a decimal. All right, so what do? We just come over here, we go 49.946 times the purple number here, 0.0435, equals this number, and we do that all 4 times in this case. And we get the numbers, and we just add them up. Okay, so we've got 4 numbers. When we add those up as I've done it, we come out with the number 52.00 when we pay attention to the sig digs that we had here. And if you look at the periodic table for chromium, it says 51.9961. Well, again, if this number were rounded off to have the same number of sig digs as our calculation, you would see that would turn into exactly 52.00. That is nothing. How do you do that calculation?